Hey guys, welcome back to math class. Well, sort of. All right, welcome back. Today we are going to talk about the last section for this chapter and for the school year for that matter, and that's going to be on compound events. Okay, so in the past we've been talking about either single trials with a single outcome, or we've been talking about multiple trials that each have their own outcomes. All right, so with a compound event, there's a couple different things that can happen. We're talking about one trial, all right, and we're talking about multiple events that can happen simultaneously with that one trial. Okay, so let's start off with a basic example, all right? So let's say we're talking about our old friend, the coin flip, right? So if I have a single coin and I'm going to flip it one time, right? There's two things that can happen, right? Two possible outcomes, all right? It can either be heads, if I can spell heads properly, or it can be tails, right? There's only two things that can happen, right? So those two have their own individual probabilities, right? If I'm only talking about one outcome, then the probability of it coming up heads, we know, is 1/2, and the probability of it coming up tails is also 1/2. All right. So if I wanted the probability of it heads, that's 1 out of 2, or if it's tails, 1 out of 2. Now, these two events, all right, on a single coin flip cannot happen at the same time, right? I can't flip a coin and it land on both heads and tails at the same time. All right, so I've got multiple events. All right, if they cannot happen at the same time, if it's impossible for them to come up simultaneously, then those events are called mutually exclusive events. All right, so a mutually exclusive event is any event or any trial with multiple events that cannot occur at the same time. All right, so for example, a coin flip. All right, that's a mutually exclusive event because it cannot land on heads or tails. All right, so this, I would say, the probability of it landing on heads and tails, all right, would equal 0, right? Because there's no way that it can land on both. So 0 out of a total possible 2 outcomes. All right, so my probability is simply just 0, okay? If I wanted to do the probability of it landing on heads or tails, right? So it can be either or if it's a mutually exclusive event. Then I would take their individual probabilities and I would simply add them together. So I would do 1/2 is the probability of it landing on heads plus the 1/2 probability of it landing on tails, and I would add those two probabilities together. Okay, so 1/2 plus 1/2, obviously 2/2, or is equal to 1. So that means that there is a 100% chance that if I flip a coin, it will land on either heads or tails. So when we've got mutually exclusive events, I'm going to take their individual events, all right, and if I want an either or scenario, I'm going to add their individual probabilities together, and that will give me the probability of either one of them happening. Okay, so another example of mutually exclusive events. All right, let's say that we have a standard deck of cards, all right? And event A, if we pull out one card out of this deck, we're gonna say is a face card. Okay, so that's event A. That's your jack, queen, or king, right? And then event B is going to be an ace. All right, so that's where we pull out an ace. All right, so we want to figure out probability of either or of these happening on a single event. All right, I can't do and because it is impossible for me to get a face card and an ace on the single card. All right, it can't happen at the same time. So I want to do probability of either getting a face card or an ace. Okay, so we're doing either or here. So I'm going to take their individual probability. So individual probability of getting a face card is there's 3 in each suit, 4 suits, so it's 12 out of 52 or 3 out of 13. So there's the individual probability of getting a face card. All right, plus the probability of getting an ace, the individual probability of that, there's 4 aces in the deck, so 4 out of 52 or 1 out of 13. All right, so if I want the probability of either one of those things happening on the same trial, then I'm going to take their individual probabilities and I'm going to add them together. And I'm going to get a total probability of 4 out of 13. So probability of getting a face card or an ace out of a single deck on a single card is 4 out of 13. So the second thing that can happen when we have a compound event is when we have 2 events that can happen simultaneously on the same trial, okay? So in other words, that all the favorable outcomes for event A and all the favorable outcomes for event B, all right, there are ones that will satisfy both events, all right, or both categories. So these 2, if they have common outcomes, then they are what's called inclusive events. Okay, inclusive events. So let's take a look at an example of a number cube. All right, so we've got a 6-sided number cube here. All right, and let's say that event A is going to be, if we roll that cube one time, that it's going to come up an even number. Okay, and event B is going to be, if we roll it one time, it comes up a number greater than 5. Okay, so let's go through and list all the possibilities that can happen here. So for an even number, right, I can roll a 2, I can roll a 4, or I can roll a 6, right? Those are all the even numbers. All right, there's 3 out of a total possible 6 outcomes, so 3 out of 6 or 1/2. All right, for a number greater than 5, all right, there's only one way that can happen. That's if I roll a 6. Okay, so there's only one possible or one favorable outcome that'll satisfy event B, and that's if I roll a 6. Okay, so I want to figure out what's the probability of me getting either or. Okay, so I want to do either an even number or a number greater than 5. So individual probabilities of getting an even, we said was 1/2. Probability of getting a number greater than 5 was 1 out of 6, okay? So based on what we talked about before, we would add those 2 together, right? The individual probabilities together, and then that would give us the probability of either one happening, okay? So if I added those 2 together, then I would get, I have to convert this, so 3 out of 6 and 1 out of 6, all right? That would equal 4 out of 6. Okay, or 2 out of 3. Now, the problem is, on this one, is that I am counting this outcome twice, okay? So I have to make sure that I'm not double counting the same outcome, all right, for the 2 different events. So I've got a total of, I can roll a 2, a 4, and a 6, and then I could roll a 6. But I've already counted that 6. You see these 2 events are common. So which means that anytime that I'm trying to find the total number of favorable outcomes, I'm going to add the individual outcomes together, but then I need to back out the total that satisfy both categories, right? So we can use what's called a Venn diagram here as well, where you've got 2 sets overlapping. All right, so event A, all right, I can roll a 2, a 4, and a 6. Event B, I can roll a 6. That's the only option. So because 6 falls into both categories, all right, that is going to be what's called our overlap. If I can hold on to the marker long enough, or find one that actually works. All right, so these are the things that fall in both categories, satisfy both events. So I need to subtract that from my probability, all right? So I'm going to minus the overlap out of there, and then that will give me my final probability, which would be 3 out of 6 or 1/2, okay? So anytime that I'm gonna do the probability for a compound event where they are inclusive, okay? So in other words, I wanna do probability. In this case, I would say probability of even or greater than 5, right? Is what I'm trying to find, all right? That's going to equal the probability of event A, right? This is event A, and this is event B. I'm going to do the probability of event A plus the probability of event B minus the probability of both A and B at the same time, okay? And we're going to use the intersection symbol. You guys should be familiar with that. So A and B happening at the same time. So I'm going to add their individual probabilities of those events happening, and then I'm going to subtract where they overlap, and then that will give me my probability of either or of those happening when they are inclusive events.